All right, this is a brief PowerPoint plus verbal overview of the online version of Astronomy 122, where I want to just discuss a few things and grunt occasionally. So why should you care about the content of the class, and what does this content gain you? And most of you are just taking this class because you have to fill some general education requirement in natural sciences, and this is one of the available classes. Well, one thing, which is a sort of intellectual theme of this class, is that the reason there's life in the universe is because of stellar evolution, which produces new elements. This represents a physical source for all of life in the universe, and really any educated person in the modern world should have some understanding of this process. Astronomy is also a good vehicle for improving overall science literacy by using it to demonstrate how science is done, mostly via observations and guessing. A lot of that in astronomy. Astronomy is a unique science in the sense that in a lot of other sciences, geology, chemistry, and physics, you can do a lab experiment or you can go to a physical location to learn more about the subject of your inquiry. Can't do that in astronomy. We have to sit back and passively measure the light that's emitted by astrophysical sources because we sure as hell cannot journey to any of them physically. So we must make use of observations because that is all we have. So decoding the message of starlight and in learning the physics from that message is really a major emphasis in this class that will be done both in the lecture notes, but more importantly in terms of actual interactive virtual observations that you'll be doing and making measurements from those virtual observations. A couple of grandiose words on the nature of science to try and suggest that your view of science is both biased and not very accurate. Fundamentally in science, and a scientific idea is one that's supported by observation and is testable and verifiable. Urban legends are not testable and verifiable scientific hypotheses. Science, in fact, is a process. It's a way to investigate nature. It's a framework. It's a set of protocols. It has nothing to do with possessing the truth. Most people think science is a pathway to the truth. It is not. Science is a process that maps everything that you don't know about a phenomenon. And science really is a process that seeks not the truth, but consistency between observations and models, because we really can't do any better than that. The unknown is already there. Science is also a way of knowing. I'm going to skip that. I'm going to skip all of this, except I've already repeated this idea that observations and experiments are reproducible, and if they're not reproducible, then they are invalid. No matter how passionately you might personally believe in something, if it's not reproducible, it's not valid. Because the world is neither arbitrary or magic. Science necessarily has a quantitative part to it because if you want to be scientific and precise for a scientific discourse, you need to use numbers. They are essential. You also need to use consistent units of measurement. Otherwise, you cannot transmit knowledge effectively. There's an inevitable conflict in all of this, and I've got 39 seconds to relay it. And this is sort of the value of this class. Science teaches us that we are in a partnership with nature. Yet human institutions often charge that nature is beneath humans. It's subservient to humans. Your future is a sustainable society, your future quality of life is determined by which of these two philosophies is practiced on a global scale, because you cannot do both. Science should be a process that humbles us by mapping out the unknown and shows us that we are in a partnership with nature. The more we behave like that, the better citizens of the planet we will be. And that's a useful reason for taking this class. Now we're done.